Today's experiment deals with Hess's law. Hess's law basically means that if a reaction takes place in one step, it will have a delta H value. If it takes place in 2 steps or 3 steps, etc., the delta H value will still be the same. So the sum of those values will equal whether it's 1 reaction or 2 reactions or 3 reactions. So that's what we're going to determine. The first part deals with determining the calorimeter constant. The calorimeter constant is calculated because whenever you do any thermal studies, energy is absorbed or given off depending on the scenario. Hopefully you realize that heat always flows from hot to cold. So when you shake someone's hand and it's cold, you know the energy from them is flowing into you. And if it's the opposite, then it's just the reverse. Okay, so to do the calorimeter constant, we take 2 quantities of water, 75 mils, one at room temperature, and then the other we heat up to about 30 degrees Celsius. We mix the two, and then we monitor the temperature for 30 seconds each. Then we find out where we get the highest temperature change, and then we go ahead and calculate that. I'm not going to show you the physical steps, I'm just going to show you the setup. Now this would be the setup. We put the water in here, we put a stir bar in, we put it on the hot plate. Now notice I've nested 2 cups together because that gives me better insulation. Then I will turn on my magnetic stir bar, and it's stirring. I will put on my samples in there. I put my cover on. This is sort of minimize energy loss. Lower my thermometer into the liquid, and then monitor the temperature every 30 seconds until I see a peak and it starts declining. And that's how I determine my calorimeter constant. So some experiments ask you to do this, some don't. Now when you do an experiment like this, you do want to use the same thermometer all the time, because thermometers should be calibrated because they're not always accurate. To calibrate a thermometer, you just put it in an ice bath and read what it reads. You can't use boiling point. You cannot use boiling point. Okay, so that is how you would get the kcal. Okay, to calculate the calorimetry constant, I have my Q of reaction plus Q of solution plus Q of calorimeter. And what I did is I took 75 mils of water, or 75 grams of water at room temperature, whatever that might be. And then I added 75 grams and 75 mils are the same for water at T2. Mix those and determine how much energy was absorbed by the calorimeter. Because I'm using a warm solution, I expect the calorimeter to absorb energy. So after going through, I found that solving for this value, I came up with 65 joules, and my temperature change was 4.33, so this would be my calorimeter constant. In other words, for every degree it changes, 15 joules of energy are absorbed or given off, either way, depending where it's going, exo or endo. So that's my calorimetry constant that we will be using in this experiment. Again, I took water at 2 different temperatures, mixed them in the calorimeter, and then plotted the data over every 30 seconds and came up with 65 joules and divided by my temperature change and got this value. Okay, in part 2, what you're going to do is you're going to take some solid sodium hydroxide, and you're going to weigh out 3 grams, and then you're going to put it in your calorimeter with 100 grams of water. Now 100 grams of water is the same thing as 100 milliliters. So in science, if someone says 29 grams of water, you know that it's 29 milliliters, hopefully. So the mass of these two together will be 103. So we're going to put those in the calorimeter, run it until we see a peak in the temperature. We'll take the temperature every 30 seconds and record that data. And then we will determine our delta T, our final temperature. So now I'm going to weigh out 3 grams of sodium hydroxide. Now sodium hydroxide is very caustic. If you get it on your skin, it will destroy your skin. It's also deliquescent, so if I left the container open, it would absorb moisture from the atmosphere and create its own solution. So when you're using sodium hydroxide, I do suggest you wear gloves, unless you're really careful, and just remember to put the lid back on when you're done getting the sample. So I will go out and measure 3 grams of sodium hydroxide. I've already pre-measured my 100 mils of water or 100 grams of water. Okay, so now I have my 100 mils of water in here. I'm going to, I got the stir bar, I'm going to turn it on so it's turning very slowly. And now I will add my So I've added my 3 grams to that 100 mils. I will lower my thermometer into the liquid, and while it's stirring, I'll put the cover on, keep it from losing energy, and I'll record the data every 30 seconds. In part 3, this time I will take a 1 molar hydrochloric acid solution, measure out 75 grams or 75 milliliters. We are going to assume a density of 1 gram per milliliter. React it with aqueous sodium hydroxide. I'm going to take a 1 molar, same volume or mass, and then I'm going to mix those together. And of course, notice they produce salt water, and I'm going to solve for my second delta H. Now notice these are both liquids, okay? Again, I'll use the same setup. I'll take my calorimeter, put the stir bar in it, add one of the solutions, and then add the other, and monitor the temperature every 30 seconds until I see a temperature change and it starts falling. I've added my 100 mils of acid to my calorimeter. I'll put my stir bar in, turn it on so it's gently being mixed. Then I will add the sodium hydroxide, the 1 molar, 75 milliliters, 75 grams. Then I will monitor the temperature every 30 seconds until I see a drop in temperature. Together these two will weigh 150 grams. Okay, in the fourth part, notice we take 3 grams of sodium hydroxide in the solid form. We add it to 75 grams or 75 milliliters of HCl in the aqueous form, and then we mix those together and we get salt water, and we'll find out delta H3. So if you notice, we are using Hess's law, and we'll talk about that in a second. So let me prep all this. Okay, I weighed out my 3 grams of sodium hydroxide. I placed my 100 milliliters of hydrochloric acid in the calorimeter. I'll put my stir bar in the calorimeter. Again, I will mix the two, monitor the temperature till it peaks, and then once it starts declining, then I can stop taking my readings. So I'll put this in. Now, if we combine delta H1 plus delta H2, it should equal delta H3. So delta H1 was, we took sodium hydroxide solid, dissolved it in water, made an aqueous solution, and we'll get a delta. I have not done the calculations yet. Delta H2, we took aqueous sodium hydroxide and aqueous HCl, mixed them, got salt water, and we'll get a delta H2. Now if you notice, if I combine these two together, these two H1 and H2, I get this equation. If I go through, I can delete the identical ones, the aqueous. So this is actually my delta H3, solid sodium hydroxide plus HCl, giving me salt water. And if you notice in my last experiment, or last part of the experiment, I took 3 grams of sodium hydroxide, added it to the HCl, monitored it until the temperatures rose and fall. And so this one, so these two upper ones should equal this one when we do the math.